Okay, we have a Hess's Law question from Alex, talking about one of the most useful gadgets ever invented in the history of the world. That is this lead acid battery, in which we have sulfuric acid that decomposes as sulfur trioxide and water, and then we also have lead. That's lead 4 oxide plus sulfur trioxide that will then give us our lead 2. So each of those has heat associated with them. So in this case we absorb 113 kilojoules of heat, and down here when we make the lead sulfate, it's an exothermic reaction where we give off 775 kilojoules of heat. Now it's important to see how they are asking this question. Okay, they want 1 mole of lead 2 sulfate based upon these two reactions where we have lead, the lead 4 oxide, and sulfuric acid. Okay, one thing to note is notice how it's not asking anything about the sulfur trioxide. So let's set this up kind of in a Hess Law way, where we have H2SO4. Actually, I'm going to do it down here. We have H2SO4 being decomposed to sulfur trioxide plus the water. Okay, and then the other equation it gives us is going to be lead plus lead oxide plus the sulfur trioxide, 2 moles of that. That's going to yield what the product they're asking for, 2 moles of lead 2 sulfate. Okay, so notice how it asks for 1 mole of lead 2 sulfate. So we know to get 1 mole we have to divide everything through by 2, including the heats of reaction. If I'm going to change that equation, that's 113, the delta H equals a positive 113. Delta H down here equals a negative 775. So if we divide everything by 2, we still have to divide those by 2 as well. Then that means we also have to divide that heat reaction by 2. And so if I divide that by 2, then that's going to give me a minus 387.5 kilojoules. That's still giving off heat, just half as much heat. Okay, so notice when I do that, that becomes 1SO3, so that when I add these together, where SO3 is on the right hand side of that equation and SO3 is on the left hand side of the equation, those, when I add those, will cancel out. Okay, so when I add these two equations together, it's going to be 1/2 lead plus 1/2 PbO2. I still have the sulfuric acid up there, plus H2SO4. I didn't have to change that at all. And that's going to yield, the only thing I have here is going to be PbSO4 plus the water. So now I have the equation that I want, where I'm making 1 mole of PbSO4. So to calculate the net change in enthalpy, then I would add this minus 387. That's my new value, plus this 113. When I do that, then simply add those two together. So it's going to end up being here 113 plus negative 387.5. Okay, so for me it's going to be 7.5. So that's where we have to shade 1, 3. And so simplify that should give us then 274.5 negative. Alright, that is the amount of heat that is going to be generated, because it's exothermic, from this particular reaction. Now, keep those sig figs in mind. We end up having 3 sig figs right here. So the answer I would put into Alex is minus 275 kilojoules. Okay, so that's pretty easy, actually easier than the ones you typically do in class. Sometimes just tricky finding out what's being asked.